Okay, so area of a rhombus. First, we need to make sure we know what the formula is for the area of a rhombus. And that says that the area equals 1/2 the product of the length of its diagonals. So that means the diagonals are added together. I'm just going to name them D1 and D2. So that's our formula. I get a thinner writing tool. Okay, so we also need to know that the theorem that says the area of a rhombus or a kite is half the product of the lengths of its diagonals. So that's our formula. So once we find the length of the diagonals, we just take half of that. So let's just make sure we know what diagonals are. And I'll put this in a different color. Diagonals will go from vertice to vertice. So I'm going to try to draw a nice straight diagonal. And then from here to here. Now we also need to make sure we understand that diagonals of a rhombus bisect each other. So these bisect each other, which tells us that this line segment is congruent to this line segment, and this line segment is congruent to this line segment. We also know, since they bisect each other, that they form right angles here. So now let's take the example that they gave in the book, and they said that that this was 15 and that this in here was 12. So since we know that this line segment is congruent to this line segment, that tells us that this diagonal, or this, is also 12. But we don't have this yet, right? We don't have that. But what we do have is this triangle. I'll put this triangle, we have this triangle right here, right? And what do we know about that triangle? Well, we know it's a right triangle, and we have two of the sides, so we can use the Pythagorean theorem, which tells us a squared plus b squared equals c squared. So our hypotenuse in this example, our hypotenuse is right here. And we know this one leg is 12, but we don't know what this leg is. So let me scroll down a little bit. So I'm just going to, I know that a squared, oops, need a pen. I know that a squared plus b squared, well, b squared in this case is 12, equals c squared, which is 15 squared. So we just have to solve for a, and that's what's going to be right here. So what do we have? Well, we have a squared plus 144 equals 15 squared. 15 squared is 225. Okay? So now we just subtract 144 from both sides, making this nice and colorful today. And I'm left with a squared equals, what is this? Let's see. 8. 222 minus 144. equals 78. And hopefully you caught that I made a mistake there. Hold on, this is 225. 225. So that equals 81. So a squared equals 81. And if we take the square root of both sides to get a by itself, that'll give me 9. So this is 9. And if that's 9, this has to be 9. So now we know that our diagonals, this diagonal is 12 plus 12, so that's 24. And this diagonal is 9 plus 9, which is 18. Right? And our formula says we take half of the product, 1/2 of that. Well, so we got 24 times 18. Take your calculator and you'll get 432. And we want half of that. So divide that by 2 and you'll get 216. And it's meters. I didn't label it, so the area equals 216 meters, square meters. Okay, sorry about this little mistake there. I wrote it down wrong. Okay, so hopefully that helps. If not, let me know.